Question 6. The function f is given by this, where a is a positive constant. Find f prime x. Simple differentiation and quotient rule. Okay? If your fx equals to u over v, your f prime x is gonna be u prime v minus v prime u divided by v squared. Okay, so let's do it. F prime x equals to differentiate u, you have 2ax, keep v, minus differentiate v, you have 1, keep ax squared, divided by x minus a squared. We have 2ax squared minus 2a squared x minus ax squared divided by the same thing, copy down. We have ax squared minus 2a squared x divided by x minus a squared. Go on to part B. The function g defined for x greater than a has the property that g prime x equals to this, and g decreases for x between a and 8. So this actually means for x between a to 8, your g prime x decreases smaller than 0. Okay, so let's go on. G prime x equals to x minus a squared multiplied by ax squared minus 2a squared x divided by x minus a squared. Okay, simply cancel this. Okay, we have ax squared minus 2a squared x. All right. Then we see ax squared minus 2a squared x smaller than 0. And if we are to do this, probably take out a, you have 1 minus, x minus 2a smaller than 0. So the critical values, and we know a is greater than 0. All right, the positive constant, right? So we have two critical values for x. One is 0, the other is 2a. And the graph goes like that. So by looking at the drawing, we know this is a portion that we are interested in. Therefore, your x should be greater than 0, smaller than 2a. Right? 2a is your greatest value that you should be smaller than. Right? Therefore, 2a equals to 8. A equals to 4. Question 7. Find the set of values of the constant k, for which the curve y equals to this lies completely below the axis. So if the graph lies completely below x-axis, k must be first smaller than 0, right? And then That also means for kx squared plus 4x plus k minus 3 equals to 0 has no solution. And which also translate to b squared minus 4ac is less than 0. My b is 4, my a is k, my c is k minus 3, smaller than 0. Further simplify, 16 minus 4k squared plus 12k, smaller than 0. And by multiplying the negative 1 throughout, I'm going to get 4k squared minus 12k minus 16 greater than 0. Okay, divided by 4 throughout, k squared minus 3k minus 4 greater than 0. Further simplify, I have minus 4k plus 1 greater than 0. Okay, now we just look at the critical values of k, negative 1 and 4. Okay, and the graph goes a U-shaped graph, and we need the positive portion of the graph. So it's this portion and this portion. So that gives us k greater than 4 or k smaller than negative 1. But let's see, k must be smaller than 0, so this is rejected. And hence, k is smaller than negative 1. This is the answer. Question 8. The line intersects a curve at 2 points. Find the coordinates of the 2 points. Alright, we can just simply equate these two. But then we realize that they are not in a standard equation format. So first of all, we can write this one as y equals to 2x plus 12. Name it equation 1 and name this equation 2. Then substitute 1 into 2. And we have x squared minus x times 2x plus 12 plus 2x plus 12 squared equals to 63. Further simplify, we have 2x squared minus 12x plus 4x squared, 2 times 2, 4, 4 times 12, 48. X plus 12 squared is 144 equals to 63. X squared, x squared, x squared minus 1 plus 4, 3x squared. And minus 12x plus 48x. So we have plus 36x. And then plus 144 minus 63. We have plus 81 equals to 0. Whole thing divided by 3. We have x squared plus 12x plus 27 equals to 0. 27, okay, basically x squared, you can only be x and x. 27, 3 and 9, 3 plus 9 is 12, just nice. Plus 3 plus 9, x equals to negative 3 or negative 9. So when x equals to negative 3, because they ask for the coordinates of these 2 points, so when x equals to negative 3, y equals to 2 minus 3 plus 12 equals to negative 6, which is 6. And when x equals to negative 9, y equals to 2, negative 9 plus 12 gives us negative 6. All right, the coordinates of intersections are negative 3, 6, and negative 9, negative 6. Question 9. A curve has the equation as given. Find the x-coordinates of the stationary points A and B. Okay? Stationary points. Whenever we talk about stationary points, we are going to use dy dx equals to 0. So left-hand side dy dx, which we will need the first derivative of the function. Simply differentiate it. We have 1. Differentiate the 1, you get 0. Differentiate the x, you get 1. And then differentiate the x squared, you got 2x. Divided by 2, you have a minus x. Differentiate this, you get negative 2 times 3 minus 6x squared equals to 0. 6x squared plus x minus 1 equals to 0. So 6 can be divided by 2x, and you have 3x. And this is positive, so the 1 multiplied by 3x needs to be positive, and this is a negative, so you have this equals to 0. Then your x is gonna be negative half or 1/3. Yeah, that's all. So you just need to find the x coordinates. And you can just assign them to be point A to be point B. Part B of question 9. It is given that P is a point on the curve where the gradient is a maximum, so that P and the midpoint of AB have the same x coordinate. Realize that they only talk about x coordinates, so we can just simply write what we have. X is negative half, A is negative half, and YA. I'm not going to write or calculate the y for point A and point B, so I'm just going to write it like that first. 1/3 YB. And this will give me my midpoint as half of negative 1/2 plus 1/3 and half of YA plus Y, and my x coordinates of midpoint A equals to negative half plus 1/3, which is negative 1/6 divided by 2 is negative 1/12. And let's talk about P. P is a point on the curve where the gradient is a maximum. Okay, note that the gradient is a maximum. Whenever we talk about max or min, we will deal with dy dx equals to 0 first, right? But this is given as a function, right? Maximum or minimum of a function. But in this case, the function is of gradient, right? Of gradient, maximum or minimum of gradient. Therefore, the function, instead of y, it must be y prime. Therefore, we need to find d2y dx squared equals to, let's see, what do we have? So this is gonna be my y prime. Okay, 1 minus x, 1 differentiate 1, you get 0. This is negative 1 minus 12x. Okay, so we have a negative 1 minus 12x as 1 minus 6 minus x minus 6x squared. This is your y prime. Okay. When this one equals to 0, then you can have a maximum or minimum point of the gradient. Okay, therefore this will give me x equals to negative 1 over 12. Do you realize this? Hence, they have the same, right? P and midpoint of AB have the same x coordinate. Shown.